manifest without it being blockable by ad blockers. We've had a customer build an entire SSAI solution at the edge. So they don't have to go back to origin. The ads are cached on the local servers, and they just insert them into the manifest and they get requested. It's been a huge improvement in their ad performance. They are very lucky, own all of their ad content, so they have great control over it. It's not a use case that is super common, but nonetheless, it's at scale. It services a very large North American population. We had another customer, actually a local, a French customer, who was able to have 20 million concurrent account authentications, verifications, and personalizations happen in 120 seconds. 20 million. Because based on their use case, they knew that people didn't sort of come and quietly enter into the event over, say, 30 minutes. They all came in right at the same time. And within 2 minutes, everyone was authenticated. They moved that entire workflow to the edge, leveraging a key value store. We've had a customer create a DRM solution, a proprietary DRM solution that services a global music streaming audience, and that DRM is completely proprietary. It's independent of, you know, Widevine, Fairplay, blah, blah, blah. They came up with their own model. And then the last one, this is relatively new. We've got a customer in the UK who is modifying their currently Dash media manifest to include content steering after the packager, because they use a third-party packager. They can't manipulate. It will be a while before that service provider will be able to support content steering, but they could do it themselves by simply leveraging compute, reading the object from origin, chucking in the content steering bits into the manifest, and sending that down to the end user. In addition, we've had people implement token authentication at the edge, the new common access token, which, Simon, I think that was the last time I was here, one of the things I talked about. The standard is now published, and these guys wanted to test it out. We did that at scale. That was a large North American customer. But we have 2 customers in Europe that are about to implement common access token. Also, implementing next generation WAF, web application firewall, at the edge. That's done via compute on our service, as well as edge rate limiting, ensuring that robots and whatnot are not able to knock you out. You can do that at the edge now, much better than you could just protecting your origin. So just to wind up, if you still think that a CDN is just for straight up video delivery for manifests and segments, you're missing a trick. It is much more capable. CDNs or compute platforms are now much more capable to deliver a lot more intelligence and improve efficiencies and performance. And if you have any questions or want to know more, please feel free to email me. I'm at the bottom there, jhall@fastly.com. But also, we have a new French team. Here in France, we have Imen and Antoine. Their emails are here, and they speak French way better than I do. I do speak French, just badly. Thank you. Sorry, that was long. Questions ou pas de questions? On continue? Est-ce qu'il y a des questions? Are there any questions? Oui. Yes.
So, just minutes. Hello. You've been explaining that you are moving a lot of to the edge, and apart from the argument that you've been saying to protect the origin, are there any other arguments that explain that, to move to the
Performance.
edge?
That's a big,
Performance.
yeah, it's a big one. In fact, the 20 million at 20 million responses delivered in 120 seconds, that was about performance.
Understood. Thank you.
Sure. Any other questions? Merci beaucoup.
On passe à la présentation au hasard. Comme vous voulez. C'est parti.
Okay, thank you, Emmanuel. So I'm maybe introduce myself for those who don't know, not in the room. I know you all know me, but on the video. So I'm Thierry Fautier. I've been in the video space for many years. 17 years at Harmonic was my record. But I've learned a lot, and I also live in United States. I created my consulting company called YourMediaTransformation, and today I'm going hopefully to show you what's happening in UHD sports streaming in United States. As you know, we talk about multi-billion-dollar contract. I know Ligue 1 is trying to get money, but here the scale is much larger. So let's look at the plan. So maybe some 4 words to explain what we are talking about. Also want to thank the people who helped me publish the blog on the subject to tune my data. Then you'll see a bit of a landscape. Who are the players? What are the leagues? Some analytics. You know me, I like to show data and to slice and dice it. Then some summary. And because this is something I've been working on before the Olympics, I was quite surprised to see Comcast showing us the bleeding edge of technology. And you will see what it is. Then conclusion, and then because we are in France, I said, okay, I have to share with you who has done what during the Olympics in UHD for all the networks, including IPTV, DTH. So, myself, based in US for the last 25 years, so I know a bit what's going on there. I was the founder and past president of the Ultra HD Forum. The first blog has been posted on the Ultra HD Forum blog, I think it was in June, and you will see the link on the blog, all the details. This is more like a summary of what was written. And also the Ultra HD Forum has created a service tracker where you have all the UHD channels, including the streaming one, and here you will have all the detail. A new update has been done at IBC. And very important, you need to be aware of the differences between the service and the users. And if you look at the tracker, you'll see some content are very popular in terms of number of service, and some content are more popular in terms of number of users. So traditional thing like, let's say HDR10, many service in terms of user, and then some others, some other format are more on the user side. So here we talk, in this presentation, we talk only about the service, not the number of users. And then last but not the least, Comcast and BCU Olympics has been doing quite crazy things, and this will be handled in a separate. So here you can see companies who have been contributing. Mentioned in this presentation are Max, who was now part of Warner Bros. Discovery. Previously was part of AT&T and was an early member of the member through AT&T. Fox has been a member for several years of the forum. NBC is a founding member through Comcast. Amazon became a member in 2023, and then all the encoding company on the planet who are powering HBO, Peacock, Amazon are also a member of the forum. So if you want to talk about UHD, you know where to go. So let's look at the landscape. So here I've put the different type of service and try to represent what are the sports. So for example, Prime, Thursday night football. Apple is also doing the Friday night baseball. Sorry, Thursday night football, yeah, Friday night baseball, plus the MLS season pass. Fox is doing the World Cup, plus some MLB, and some NFL. This devil is in the detail. Peacock is doing the Sunday night football. So you have the Thursday, the Sunday. Paramount Plus is doing Champions League. And Max is doing NBA. And for those who read the news, they have lost the right moving forward. So there's some litigation going on. So as you can see, those are the major service providers and those are the leagues from which they license their content. So this table is quite busy. So I try to put in one table what are the service, what are the sports, what are the leagues, what are resolution, HDR, UHD, and is there any low latency, since people talk about low latency for several years. So you can see we have a mix between 1080p 60 HDR, 2160p HDR, and then it's a mix and match, so depending on the sports, so you see some content streamers are more on 1080p, so are more on 2160, but we still have at the bottom, I put that in gray, those that we call the bad children, because they are still in 1080p 60, they have not opened the HDR book. Some of them is because they don't get the feed in the right format. Some of them is because they don't have a complete workflow to support HDR, or some of them just do not care about HDR. It's not a priority for them. Any question on this table? And you see there are some footnote like Amazon Prime is low latency using the SAI UDP protocol, not very friendly for CDN. And then the second one is Paramount. Outside US, they have 1080p, so HDR, which means that depending on the continent, they have a different approach to customers. Any question on this table? It's quite a busy one. So low latency is basically what is coming close to broadcast latency. It's not ultra low latency. For example, on Sky today, you have 1 minute difference if you are on TT versus broadcast. Comcast, 1 minute between Peacock and Comcast. So when I watch, for example, on the mobile, my wife is telling me, oh, just check the goal. So I don't talk to my wife during the game. It's a bit tricky, and you'll see what Comcast has achieved. We don't talk about ultra low latency because I think it's a different market segment. Very important, this not only on streaming, like traditional streaming direct to consumer. Here we also have what we call the virtual, it's not N, so it's virtual MVPD. I made two mistakes, I can't believe it. So basically YouTube TV's broadcasting Super Bowl because this was provided by a broadcast channel. So you could get 2160 HDR10, and then they have also their own content, which is the football Sunday night ticket, but 1080p SDR. They don't want to invest in 4K for streaming, and they don't want to invest in HDR because this is their own rights. They decide what are the technical parameters. Then you have Fubo TV on the last Super Bowl was 2160 because it was on Fox, HDR10. And you see they also do EPL, 2160 HDR10. So it shows you that it's possible to stream 4K HDR at scale. And those people, I mean, if you look at the largest one, I think the one who was doing 50 million, where's Jim? He's gone. 15 million, that's what you get at Amazon Prime today. It's the highest. And the one in 2160, I would say Fox Sports, yes, probably. The World Cup was probably in the 5 to 10 million concurrent sessions. So it's quite decent. So let's look at the service-based analytics. So what are among all those services the popularity of each format? And you see the number one is HDR10, 63%. Number two, sadly, SDR, meaning I don't want to make effort. And then a small Dolby Vision island. So it shows the most popular, this is the distribution format, of course, most popular by far HDR10. Here, it's also interesting to see the resolution. There's a lot of debate, people telling you, oh, UEFA, in Europe, it was 1080p HDR. Why do we need 2160? Well, the proof is in the pudding. In terms of service, 47% of the streamers are in 2160. 32, sadly, 1080p HDR, but we still have 21 who are already in 1080p HDR. Comcast was offering two things. On the Xfinity service, which goes either to your set-top box, but also to a connected TV, which means Comcast was streaming 4K ABR, which could go to either set-top box or connected TV. So it was the first time we had the Olympics for the whole games in Dolby Vision live. Of course, it's UHD, but also they had low latency implemented, meaning they were mentioning 42 seconds ahead of any other virtual MVPDs. They call it MVPDs, but actually other streamers. So they were 42 seconds ahead of anybody else streaming. So for them, it was quite achievement. And of course, the second thing is that they could do set-top box and connected TV. So basically, the bet of Comcast is to say, multicast, TS whatsoever, we don't want to do. We want to go to our set-top box in ABR, but also to the connected TV, same feed. Peacock belongs to Comcast. The streaming element is very, very conservative, 1080p SDR, meaning that this is the bottom of the pile. But maybe they think it's PC, it's mobile, it's young generation. If you want the high quality, you go on TV. But if you are not a Comcast subscriber, too bad for you. So there is some interesting conversation happening. So in summary, it's encouraging to see that some major events like Super Bowl, Kentucky Derby, and we see also similar things happening with the FIFA and the Olympics. UHD is being streamed either in 2160p 60 HDR or 1080p. 1080p services HDR are all migrating to at least 1080p HDR, but they do that at their own pace. Both basically technical teams saying it's not possible, or if it's possible, only on some device and whatsoever. Comcast Xfinity has really pioneered at the Olympic for several reasons. First, 2160 P60 streaming on the managed network, so that's maybe less challenging than traditional CDN. Dolby Vision, low latency, NGA to a connected TV. Interesting. So to summarize, HDR is deployed in the United States for sports, 2160 HDR for large one-off events, the Olympics and the Super Bowl. 1080p HDR for leading recurring services. I put in this category Amazon, for example. They are leading. They are doing whatever it takes to make the best service. 1080p SDR, I call that lagging recurring services, people who have a match every week. NGA, still confidential. Dolby Atmos, MPEG-H, not very well deployed. Low latency is available now through SAI, Amazon SAI, or CMAF, low latency HLS and Dash. And for me, the 2160 P60 HDR low latency in service on set-top box and connected TV at Comcast was a breakthrough for those Olympics. Any questions on this US streaming? You need to take a mic.
Hi, Thierry. Why is it still in such a low adoption? Well, in your opinion, why aren't they have the capability, they have the bandwidth. Yes. Why is it still not UHD everywhere?
Yes. So first question for all the audience, I'm going to do a poll. out of Netflix and Amazon libraries, what is the percentage of their library which is UHD? 20? Higher? 20-ish, depend on the service provider. So already on VOD, there are new titles coming in, but there are still content producers who don't get enough money on UHD, so they get on the HD to come to Netflix, Amazon. So it's not 20 is not high. So here, yes, of course, you have a lot of people streaming HD today, but if I take the bad guys, so Peacock, Paramount, Apple, NBA, I think they are limited in their current workflow to deliver a 2160 HDR experience. I can tell you Amazon, because of the scale, you were not here, but I was mentioning 15 million concurrent users. You need to run some math before you move from 1080p to 2160. The bill is twice. I know your company, you say 4, okay, we can discuss at the bar. But it's a lot. And in India, 50 million concurrent sessions on mobile phone at 800 kilobits per second. So you have to be careful when you say how many sessions is what's the resolution. So I believe eventually there will be the first step of the scale, which will be 1080p HDR, because people have TV, people are enjoying it. And for sport, you can debate, which is another EBU-ish discussion, 1080p HDR versus 2160 SDR. We know 1080p HDR is better. Now, 2160 HDR only shines if you have 65-inch and above TVs. And then you have the nits discussion. How much do you pay for your TV? $300, you have 100 nits. You think you have HDR. So there are a lot of topics to consider. We all agree eventually it will be 2160 HDR. I think there will be one step at 1080p HDR, which is, where's Philippe? Good enough. It's good enough. Don't get me wrong, I prefer 2160. The studio guys, they don't want to hear about 1080p 60. So this is rip-off. Don't buy that. That's the studio people. They don't pay the bills. Did I answer your question? Thank you. I try to be honest, because I know the challenge. I see the duck pedaling under the water sometimes. It's not always simple. Any other question? Yes.
Do you have any numbers for high frame rate?
Oh, is that them in the room? No. You remember Forever project?
I do.
So they did a lot of experiments on some sports. They were discovering there was a benefit to do that. The problem is, if you look at France Television, I hope I'm not going to hurt anybody, by July 2024, they were barely able to produce 2160 P60. So IOC, if you know the workflow, has no P120 production. So nobody is going to provision a head-end for P120. What you could tell me, but if I do 1080p 120, it's lower than 2160, blah, blah, blah. At the end of the day, my take on high frame rate is interesting for some sports, cycling, maybe some soccer when you have Mbappe who's really making a nice shot, slow motion. But this is only something visible for maybe 10% of the population. So you have 10% of the sport, 10% of the action in this sport, 10%. So you are below 1%.
And so the opposite question is, do you know of any service, sports service that would be with 30 frames per second?
No.
It's
this
only
is
60.
disallowed. You can't do that. You are fired. But if you work at Netflix, you are the star. P30 is very high. Okay? No, no, Jim, you already used your token.
Just a question, not directly related to UHD, but do you know if Comcast also had some SSAI together with low latency and UHD during the...
Oh, yeah, yeah. This is a loaded question. Simon, can I play my joker? So
Okay.
I have always said from the beginning that low latency, SSAI, connected TV, watermarking, if you steer that together, you might not cook a well-cooked dish. And for that,
Agree on that.
I will send you to SVTA, Interoperability Live Group, and there are still scratching there. I don't think we have seen today any commercial service with all the combinations because it's extremely difficult, at scale. And this is back to my friend Jim. At scale. At scale. Has to scale. 10 million subscribers. And then if you add UDP, SAI in the mix, then I think you talk only to one company. The goal is to scale. Multiple CDN, multiple device. It's challenging. But that's why we have all those groups as VTA. Because we need to make sure multiple vendor SSAI from you, low latency from the other guy, watermarking from a third guy, and then the CAT authentication and the content steering. I think we see that there are many, many, many techs to be added together to make it work at scale. This is going to be challenging, but we have to do it. That's why it's good to have those groups, I think. I'm a believer in interoperability. Okay.
I have one question.
No.
Yes. Do you have any numbers of the actual number of viewers that were watching in HDR?
Yes.
Or they support HDR, but maybe 90% of their audience was watching in SDR.
No, in general, when you get HDR in, it's because your TV or your client recognizes you have a capable equipment. Now, if the user is stupid enough to switch after the set-top box to SDR...
I'm asking about your device penetration, device compatibility.
I can tell you, for example, in France, there is 70% of devices which are HDR capable.
But HDR10 or Dolby Vision, so the
HDR10. Dolby
HDR10,
Vision,
okay.
Dolby Vision is another complicated topic, but that's why you see in the TNT spec, HDR10, they test, they send Dolby Vision, they measure how many TVs are surviving, but in US it was only Dolby Vision. I'm not telling you how many set-top box were able to talk to Dolby Vision TV. That's why I say be careful between service and device. You have a lot of discrepancy. You go to Service Tracker in the Ultra HD from website gives you per service, per HDR, how many estimated service, how many estimated consumers.
Okay. So Thierry, in France we have the film du dimanche, donc the Sunday movie.
Yeah.
So I wonder if it will make more sense to broadcast UHD content only when it makes sense, like once per week, only on the Sunday.
Yes.
Instead of having like a full system with upscaling all over the place. So what's your take on this?
Yes. So first of all, I was in a panel at IBC. There was the BBC guy, BBC iPlayer, who is doing episodic streaming of UHD content, 4K. HDR. And there was the poor Chinese guy who was zero UHD library, say, I'm going to start 100% upscale. Those are the two extremes. You need to be pragmatic at the end of the day. I think it makes sense to have a channel where you have the premium event, like Canal Plus is announcing they do 24/7 UHD channel. I can tell you it's not 24/7 original UHD production. It's impossible. So they will do a good upscale offline. They post that on the playout server, and then they will be able to encode it and to distribute it as if it was UHD. Did you guys check the quality between France 2 upscale by France Television, channel 52, versus France 2 SDR 1080i upscale by the TV set? Did you guys run the experiment? And same, no difference. What size of the screen? 65, no difference. So you have a good... Okay, and you had... But what quality of TV did you have? A good quality or poor quality? No, the TV, when you take the LG OLED, so good one. Okay. So let me give you my take. The expensive LG OLED TV, it's few percent of the population, and then you have mid population where you have okay processing, and the mass, probably more than 40%, is poor processing. And when you send 1080i on this TV, you will get nothing. You'll get edge problem on the transition, you know, the track and field, Stade de France. It's going to be a disaster. So the challenge is, if you say, yes, the TV can do it, my question is, what's the percentage of the TV that can do a good job? And will people realize the quality is not that good? This is up for the bar discussion. Okay, I give you a few more slides, and after that, I go to the bar. So, Paris Olympics. So as you know, France Télévisions, well, IOC was giving to OBS the task to produce 100% all the Paris Olympics in 4K HDR. After that, you had two distributors in France, France Télévisions and Eurosport. So I'm going to talk about the signal that went from the France Television head end to all the different distributors himself, DTT, France Sat in DTH, IPTV, many operators, including our friends at SFR, but Orange, Bouygues, everybody had it. Direct to consumer, it was France Television. And then, let's not forget Canal, OTT, My Canal, and Molotov TV. So as you can see, the only bad guy was France Television, direct to consumer. It was not HDR. All the rest was between 2160. Actually, they were all 2160. There was not even 1080p HDR. You saw in US, it was a big number, like 13%. Okay, and you see some footnote. I'm not going to go to the detail because I will eat up all the time. But interesting to see what Eurosport was doing. So they have their own Max app, 1080p 50 Dolby Vision, with all kind of fancy audio at very low bitrate, 12 megabits. IPTV was SDR. This is the decision from Max. DTH on Canal Sat was Dolby Vision, 2150, very nice. And on my canal, it went 2150 Dolby Vision, also very aggressive in terms of specification. So to summarize, France TV didn't stream in UHD OTT, but left the job my canal and Molotov. I must say, for the first time, ISPs, so the IPTV operator, have stepped up, offering a similar experience as for DTT. If you recall, during the World Cup and the Olympics, it was still 2150 SDR, which is a complete waste of time. Nobody's doing that anymore. 1080p HDR is a marginal format as opposed to what we see in the US. 2160 HDR is the norm for DTT and OTT. And AG Atmos is only deployed on broadcast network, DTH and DTT. Voila. And if you want to follow me on LinkedIn, feel free.
We have time for one or two questions.
So you mentioned the ISP and the support of lack of support of HDR during the World Cup. So what's happened between the World Cup and the Olympics? Did it change the set-top boxes or?
No. I won't talk because you have our friend here from SFR, but I think it is a lot of work to upgrade the set-top box first, change the set-top box, upgrade the firmware, make the test. So this is a lot of work, and I think maybe the World Cup was too not estimated to be important enough. I think when you have the president saying that UHD is a priority for the country and 60% of the people still see the same old 2160 SDR, I'm not sure he's going to lose the election, but it's a bit frustrating. It's like swimming to the Seine for $1.4 billion. Is it worth doing it? Similar thing. I think the operators have realized they have to step up. And at the end of the day, I think only Free was simulcasting 2160 SDR and HDR. All the other IPTV operators were taking the France Television feed, not encoded by them. Pass through. We evolve. We learn from our mistakes.
Thank you, Thierry.
Merci.
Now, Yoann. Yeah, the cheerleaders are in the front row.
Hi everyone. So I'm very happy to be here with you in Paris. Thank you for the Paris video team to have organized this. When I proposed the speech, I had a nice discussion with Simon, and he said, "Can you tell me about it? Because I want to make sure. Je veux vérifier que c'est pas de la flûte." So I hope that you will like it and that you will consider that c'est pas trop de la flûte, and that you will like what we'll be discussing about today. I'm Yoann Hinard, Chief Operation Officer at Witbe. Based in New York for the past, I moved there 4 years ago. I've been working at Witbe for 15 years now. And at Witbe, we do test and monitoring. So what I will show you to do today is based on that. So today we'll be talking about the video, especially in the context of mobile networks. So you all know that video have been using a lot of data and throughput in the different mobile networks. Some of our customers are telling us that sometimes only one single application can take up to 40% of their network usage. It has been reported that it can be more than 70% of the overall usage for the mobile networks. It's supposed to grow, but obviously Ericsson is saying that it will grow because it's also in their interest. And the question is that, as opposed to the fiber for the broadband, we can see a lot more of deployment for the mobile network, and it's very sensitive to the load because it's a shared medium. We all access the same bandwidth spectrum, and it's shared between the user. Obviously, you can add more cell and have a smaller range of deployments in order to increase the number of users that you can put, but it's always a discussion where you want to go and what is the limit to the number of cellular that you can put. Also, we have a lot of fixed wireless deployments, so instead of having the fiber to the home, having the 5G gateways, which also provide a big hit on the mobile network. So everything that I'm presenting after is real capture data. So it's not simulation. It's not based on either simulation or emulation. We really capture the data using real devices. So here it's a mobile phone. We use, in this example, TikTok. Please bear with me with the video. It's not the one I chose. The robot has been profiled as someone who likes this stuff. Not my fault. And the robot is measuring and using a real device. So it's a real device using the real application, production version, real network, real environment, real SIM card, real everything. It's really as you would do, swiping. Maybe you don't, but as some do. swapping up and doing different sessions. So in the different results, I will detail a bit more the parameters that we use. And once it's done, we look at what's happening on the screen. So we have a reference video quality assessment that will look at the decoded pixels. We don't try to look at the network to guess how it should be looking on the screen. We really look at the screen and detect what is the perceptual video quality. For that, we look at the different defects that we can see on screen, like blur, jerkiness, macro blocking, in order to compute the most scoring. So the different results are being measured on different applications. So for the implication, we use Facebook, Instagram, TikTok, and YouTube Short. So all the 4 main applications which are used in the US. The pattern, the test pattern was I launch the application, I go to Reels or other, I go to the video, I do 50 swipes every 10 seconds. So 1 swipe every 10 seconds. And we are measuring initial buffering time, video quality, rebuffering, and also at the same time, and this is where I want to go, the amount of data which is used by the application. So we directly capture the traffic which is being done, generated by the device itself. Obviously it's not so obvious, but we are not putting a proxy in the middle, because if you put a proxy in the middle between the phone and the cellular network, you will totally mess up with the way the application behaves in terms of network transport, protocol being used, whether it is on HTTP quick, HTTP 3. There is no way your proxy will behave the same way as the application will normally do toward the real service. And also because most of the proxy that you can put in man in the middle would be also limited to either IPv4 or IPv6. In a word, if you are in the middle, you are totally messing up with your measurement. So here, directly capture from the device as a black box, non-intrusive. So in terms of number, that means more or less we do 10,000 swipes a day on every application. And what is very interesting is that we did the exact same type of measurement, same location on different network with real SIM cards. So different SIM cards from different providers in the US, as well as some lab environment with purposely impaired radio network to see how it's behaving in bad quality environment, and very good Wi-Fi connected behind a GPON access. And the goal being to see if there is a difference, because, and this is where we will focus on what you can tell and what's happening between the two. So here the bar graph are the bandwidth being used over a session, average bandwidth. There is a mistake here, it's not kilobyte per second, which would be 100,000 kilobytes, it's a lot. It's 100 kilobyte average byte, so 800 kilobit per second, average over the session. Why it can be considered a bit low sometimes? It's also because there is some prefetching from the application, some cache which has been already done. So it's over a session and with swipes every 10 seconds overall. And the line in blue is the video quality which is measured as a user. So it will be impacted by poor initial buffering time, rebuffering, frozen screen, black screen, error screen. So every defect that you can see on screen. I won't detail every single piece of information, but one that is very interesting, just to give a hint of, is there any difference or not? Here we take one of the applications. So one of the 4 applications I mentioned before, and you compare how it's behaving between operator 1 and operator 3. So we can see first that on the good Wi-Fi, the application is very data greedy. It's the one that is using the most data in very good condition. And in operator 3, this is also the one that is using the most data. But in operator 1, that's the one that is using close, except for application 4, close to the least data. So that really highlights, at least in the US, that operators are really doing some active traffic shaping and throttling in order to change the way the application will behave. Same application, same build, same phone, same location. And it's not because we were just on a very low coverage for operator 1, because you can see that other applications which are not so greedy usually, like application 3, were able to top up much higher in terms of bandwidth usage. So here the question is, how can I find this sweet spot? Is there any sweet spot that you can find between data usage and quality of experience as seen by the user? Especially in the context of vertical video, because does it make sense to encode a video that has been captured, recaptured, add a meme put on top of it, and put it at 12 megabits per second in order to be able to slide? Obviously it doesn't. And the question is, how can you optimize all of this in order to reduce the footprint while maintaining a correct quality of experience in between the user? As an operator, do not have your user switch to another one. As a social media provider, not be cut off and be thrown out by the network operator who are fed up with having such a high distribution cost to send video of cats. So here, we're looking at the throughput, so between different applications. So here we have Facebook, TikTok, YouTube, Instagram, and we can see that the profile, the way they try to top up, not only is different, so you can see that we have clearly different part, but also is different from time to time and depending on the content. And at the same time is how it's impact the quality. So here we have some spikes in the quality, so some defects. We are measuring here the raw buffering and initial buffering, and we can see the percentage of sessions which are having some issue in the raw buffering. But what I like to highlight, this one is one of my favorite one. Here on top, you have the version. So yellow, obviously you cannot read anything. It's all right. So Instagram, you have multiple versions, the yellow one, the green one, the orange one, and the blue one. Sorry if you're colorblind, but basically it's 4 different colors here. And what is interesting is that starting from the blue version in the square, we can see that the pattern of usage change. So it's also highlighting that what is true today may not be true tomorrow. Because obviously they want to improve and they want to reduce their data usage while having a good quality. But here, we have been able to measure this effect and to measure how they were behaving. Also, an interesting factor is to see how these applications behave when there is poor network connectivity. So either by actively impairing the network, like adding delay or attenuation or noise in the mobile network, and seeing how this is seen by the mobile phone directly, the typical KPI like RSSI, the signal level or the signal to noise ratio, affect the way they can top up in terms of bandwidth, but also in terms of quality. And to go back to throttling, so here throttling, we have 3 different profiles that are being tested. One which is uncapped, so this one is on the NBA application. So again, vertical swipes. Uncapped, capped at 1 meg and capped at 5 meg. So something which is interesting, so if we are capped at 5 meg, you can see that it's the line here is more or less around 5 meg, so it's really stable, able to top it up pretty much all the time. Cap at 1 meg, obviously it's really very flat, it's the bare minimum. And uncap. And uncap, it's not so, it's not moving a lot, it's fairly stable, and the range that it's using is not a lot. And the good thing is to also look at the quality. So here we are looking at the VQMOS, so the higher is the better. So when you have something which is very flat on the uncap, it's very good. And you can see that on the cap at 5 meg, even if it was using a lower amount of data, most of the time it was all right. It was all right for most of the video, but this increase of data also allowed the buffer to be taken for a bit longer and is much better in case of a lot of movement. So the average is mostly the same, but you can see some spikes going down. So that means it will be overall the same quality. So if you look at it for 10 minutes, it should be all right. But occasionally you'll get some drops on the way. After, the question of are the drops acceptable or not also depends on how the competition is behaving. If in New York you have a Verizon T-Mobile, does it make sense to use 30% additional data to be twice as good as the other one? If you're already on par or maybe 10% better, that might be already way good enough and not make sense to use additional data. Let's close that. Now to the field application. So early this summer, I don't know if you have seen this press release, Telefonica Europe and Meta released a joint press release about how they optimize short-form video experience and promote mobile network efficiencies, and also Vodafone and Meta. So you can see that it's same type of improvement. This initiative have been around how to make a better usage of the network, which is obviously great for the resource usage, but also obviously great for the cost directly. So that way of being able to measure can lead to this kind of really field improvement to see what you are touching. If you are touching something, it's hard to know and know for sure how it will end up behaving on the other side, at the customer side, and how it's behaving, especially because the parameters are very, very moving. As we have seen with the version which is changing, even if you can make up the ideal machine learning helped simulation that is very perfect, 99.9% right now, it may be untrue 2 months after, just because they have moved to HTTP3 and it totally changed the game. It can be more aggressive, it can behave differently. They can change the prefetching parameter, which is the amount of video that will download in advance. All of that could change. And by working together, they can, let's say, they can end up in a deal where they can not be throttled that much in exchange of not be greedy enough to take everything. So it's a fair use. Okay, I can give you more room when you need, but please, when you don't need it, take your time and it's all right. Maybe 100 milliseconds between the swipe is acceptable as an initial buffering. You don't have to be frame to frame already that close.
I have been moving in this story, only one in Asia, and it's
Thanks, everyone.
Questions? I have one. Do you think some mobile operators are actively rate limiting some services? And if yes, how does that work with the net neutrality?
So yes, I'm sure of that. We have measured it, we have discussed with mobile operator. After, I'm not 100% sure that it's not fair. So for example, in the US, you have AT&T, which provide by default a capping on so they generate a throttling on their network access, which is advertised. When you go on the website, they advertise it as UHD capability. And this is an opt-in mechanism. So that means even if you take the subscription that allows you to get it, if you don't go in your settings, opt in to get it, your video services will be throttled by default. After, the question is how do they detect that it's video services and not something else? That is not information I can disclose. And yeah. In Europe, I don't exactly know, and I don't know what is being throttled, how it's being throttled, and especially if it's between different applications. But we also see that one thing for that some of the provider provide out-of-package priority access. Telefonica in the UK have been doing that with Amazon Prime. That means if you are using Amazon Prime, you are not being charged for the data which is consumed as part of this consumption in your data cap. So they still have to measure it, put it out of the data cap, and this fair use policy does not apply to the data which is being used by Amazon Prime.
Something to say, Bouygues Telecom?
I wouldn't answer as a Bouygues Telecom, but as a net neutrality perhaps aware. You could throttle traffic in the case of congestion, as it's okay for net neutrality. So you could retrieve it in the regulation.
And can you throttle it in order to prevent congestion?
In order to avoid a network collapse. So
okay, so okay, you can do it before, during, and after to provide that it's not coming back again.
But when it begins, what is the congestion definition? Is very fuzzy concept. Yeah.
Thank you for the feedback.
All good. Thank you, Yoann.
Thank you. Thanks, everyone.
And so now, next step, beers again. So we'll all go to the bar Les Marquises, the same bar as usual. They're waiting for us with beer and charcuterie. Thank you.